Hey everyone, this is Subnet Zero and welcome to my channel. So in this specific video, we'll be focusing on the calculation of CIDR, okay, how it is calculated and the hacks we'll go through how we can make the calculation easier. Before we proceed, few instructions I want to give you. Please, this is a very math and a logic heavy video. So please ensure you have no distractions. There are no dogs barking. There's no Instagram reels going on. There is, no distractions, any potential distractions anywhere. No one is yelling, screaming, absolutely nothing. I need your undivided attention in this video because if you are able to understand the calculation behind this and how this works, I promise you the rest of the videos from now on will be like a cakewalk. Okay? So without wasting much time, let's get into how CIDR is calculated. So just to give you a brief recap of what we did in the previous one before we go ahead, I provided you this diagram, right? This one, the number in pink, and the binary conversion. Let's go through it once again. I'm going to use blue for this. Yeah. The binary number conversion of 192 is this one, which we call as the first octet. The binary conversion of 168 is this, which we call the second octet. The binary conversion of 0 is this one, which we call the third octet. And the binary conversion of 1 is this, which we call this as the fourth octet. Okay? Let me just, yeah. So now that this is clear, you see the /24, right? So it completely depends upon what number is. In the slash, it could range from 0 to 32. But within this range, if you want to calculate how this works, so you see the numbering system, the slash numbering system over here in pink. If you are watching this on mobile and if you can't see, if the formatting is too small, because this is the best formatting I could come up with, either see it on a big screen or you can zoom in from the YouTube video itself. Okay, so if the slash notation is between /24 and /31, okay, anywhere between this, which means only the fourth octet will change. And if the fourth, what do I mean by the fourth octet will change? The fourth octet is what we call will be the host. It could be between 0 to 255, okay? And the first octet, the second octet, and the third octet all are locked in. They are network, and network. This won't change, okay? This is what I mean by the CIDR calculation between /24 and /31. Now let's pick a different color. If the slash notation is between /16 and /23, which means the third octet and the fourth octet, they will change. Okay? So then the third octet and the fourth octet will be the host part. The first octet and the second octet will be the network part. Okay? If it is between /A to /15, you can guess it. The second, third, and the fourth octet will be the host part, and the first one will be the network part. That means this will be locked in. Fair enough? Now let me pick a different color. Yeah. If it is between /0 to /7, that means they are all host parts, which means we are having a gigantic network. Most of you will not come across such a scenario, but this is just so that the logic is solidified. Okay? So now that this is cleared up, we will get into some examples of how the calculation works. So I've just cleared up this board and let's get into the calculation part of it. Okay? So in this one, if it is /24, like let's take this example, okay? This very much in front of us is 192.168.0.1/24. Let me just clear this out. So if this is /24, where does /24 fall? In this one, that means this only the fourth octet will change. When I mean the fourth octet will change, only the fourth octet, which consists of the host part, will get updated. Let me demonstrate. Over here, you see this? I've created like a mini template. So after looking at this template, you'll understand how this works, okay? For a better idea. So this means, in this case, 192.168.0. Yeah. Just one second. When I've created this template, It means the first, second, and third number will be locked in because the network parts. The only part will change is the host part, which is the fourth octet. That's why I've named it as X to provide flexibility. Okay. So if it's /24, what would it be? Now, for your reference, I've created a cheat sheet for you. Just one second. Let me just adjust this properly. Yeah. This cheat sheet for you. What does this cheat sheet do? You see the one in gray over here? In this gray, it's the slash notation. So whenever, if you're not sure of anything, just go to the slash notation over here and see, it'll provide you a hint where it goes. So over here we have /24. So let's look at that cheat sheet. Our /24 is this one. You see this? This is /24. And the number what we have here is 1. So where does 1 fall in the /24 column? So /24 column, 1 falls between 1 and 255. Why 255 and why not 256? Is because 0 to 255 is one batch, 256 is another batch. Or let me make this even clear. If you look at this example, okay? If you are checking a chunk, the network block, it will be from 0 to 127 is one block. 128 to 255 is another block, okay? And 256 is like a concluding block. Similar to here, 0 to 63 is one block, 64 to 127 is another block, 128 to 191 is another block, 192 to 255 is another block, okay? So like this. And 256 like a concluding one, you can skip that. But this is how the numbering system is. The further we will go, the more we'll look at examples of calculation, the clearer it will get, okay? So anyway, this is from between 0 to 255. So which means network will be 0, 255 will be the broadcast, okay? The others in between will be 1 to 254. And if you're not sure, just let me just adjust this. Hold on. Yeah. And if you're not sure about the calculation, if you want to double check, there is a link I've provided to you over here. You see IP subnet calculator. Open this up, and 192.168.0.1 is that the one that /24. This is, you see this over here, /24. Let me just zoom in over here. Yeah. When we calculate, what would the result be? Okay. See, you see the network address over here, 192.168.0.0. We've got that. 192.168.0.255. You got that. And let's check out the usable ones. 192.168.0.1 to 192.168.0.254. Let's check that. Let me just copy this, paste it. Let's check it. See? 192.168.0.1 to 192.168.0.254. So this is how we calculate the network address, the broadcast address, and the usable IP address in this range, okay? So this is a simple version. Let's look at examples as /16, /8, and /0, and how it gets. And the further examples that we'll go through, the better the idea you will get. So now that we have done /24, let's look at the examples of how would it be with /16, /8, and /0. Again, let me repeat it once again. /0, majority of you will never come across. But this is just to get the logic of it rock solid. Make sense? Yeah. So now this is like /24. Let's make it /16. Where does /16 form? /16 is over here. That means the third octet. And if it's a third octet, that means third and fourth will change. Yeah? Third and fourth will get updated. 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 And why will it get updated? Is because they are the host part. The 192.168, which means they are network part, and they will be network ID, network part. That means they will be locked in. Okay? So in /16 is the third octet. What is the third octet? Let me just choose a different color. It's this one, 0. Where does 0 fall in /16? Let's open up a cheat sheet. 0 falls between 0 and 255 as expected. So this will be 0 and this will be 255. And now if this is 0 and this is 255, this 192.168.0, it will begin at 0, and 168.255, this will end with 255. Okay, and everything else in between will be the usable one. This will be 0.1, and this will be 254 to 255. Want to check? Let's check. /16, calculate. See, 192.168.0.0, we've got this right. Broadcasted 192.168.255.255, we've also gotten this right. Now let's look at the usable ones, okay? 192.168.0.1, we've gotten this right. I've copy pasted that just so that cross-checking is easier. 192.168. Sorry, my one mistake. It will be 192. My bad, my mistake. I apologize. It will be, this is correct, 192.168.255.254. Why is that? I'll explain that later, okay? 192.168.255.254. So this is, we have gotten it correct. Now, some of you will be getting confused. How is this font, this one, usable in this one? So, let me show you in motion how IP addresses is incremented, okay, with each increasing binary value. This visualization will provide you how it works. So I've created this kind of like a simulation of how it works. Okay, let me just ensure this 168. Yeah, I've created some kind of like a simulation, like a working model of how it works if IP addresses increments by every single binary digit. And if you see this in motion, it'll absolutely get locked into your head. So next time when you see the incrementing numbers in like the third octet or the second octet, so it won't be as overwhelming, okay? So for your reference, let me show you how incrementation or incrementing. Sorry, my English, sometimes my language becomes a little messed up, but okay. How it increments, let me show it to you in the binary numbers. Okay, 192.168.0.0. Let's say this is like the base we have. So it increased from the fourth octet gets triggered first. Let me use the color, I don't know, of let me use this color. Okay, fourth octet gets triggered first. Then third octet gets triggered second. Then second octet gets triggered third, and the first octet gets triggered last. What do I mean by that? Let's go one by one, okay? So 192.168.0.0 is like our first example we have. Okay. Then the next one will be 192.168.0.1. This is the next incrementing number. Then 192.168.0.2. This is the third incrementing number. Okay? Sorry. Yeah. Then we have 192.168.0.3. Then 192.168.0.4. That's how it increments. I'm not writing everything over here because then we have limited space and time. But you should intuitively understand the gist. Then there's 192.168.0.5, 192.168.0.6, 192.168.0.7. Like that, it keeps incrementing, keeps incrementing, keeps incrementing. It keeps going, it keeps going, it keeps going till it hits 192.168.0.253, 192.168.0.254, and 192.168.0.255. This is when we hit the lowest limit. This is the uppermost limit, this is the lowermost limit, okay? Once it hits this, the entire, the third octet increments to 1, and then this gets incremented to 0. This is the next number and the highest value of the next batch, if that makes sense, okay? So now, let me just reduce the format. Yeah. Now this will be 192.168.1.0, then it will be 192.168.1.1. Let me just add this over here. Then this will be 192.168.1.2. Then this will be 192.168.1.3, 192.168.1.4, 192.168.1.5. It will keep going, keep going, keep going, keep going till it hits 192.168.1.253, 192.168.254, 192.168.1.255. This is like the lowermost limit of the second batch. Yeah? I hope that you've understood this. Now, we have understood how fourth octet increments and third octet increments. Now, if you look at the second octet, how this further increments, okay? So, if let's say this will go from 192.168.1.255, then it will go to the highest uppermost point of the next batch will be 192.168.2.0, and the lowermost batch of the lowermost number of the next batch will be 192.168.2.255. Then again it will get reset. This will get back to 0, and this will go to 3. Yeah. So now I'm sure you must have understood how the incrementation works. Okay. When over here it hits 192.168.255 to 254, then it hit 192.168.255.255. Once it hits this number, the very next number would be 192.169.0.0. Yeah? I hope that makes sense. Let me write this down. 192.168.255.255. Once it hits 192.168.255.255, it will be 192.169.0.0. Again, all this is based on the fact that 0 is the lowest number and 255 is the highest number. Please tattoo this inside your head. Ensure you never ever forget this. Permanent tattoo. Absolutely. No amount of tattoo removal should able to remove this. 0 is the lowest, 255 is the largest. Now, given that this all based on this logic, this is how the binary gets incremented. Okay? I hope now this makes sense. Okay? Why is it 192.168.0.1 to 192.168.255 to 254? Okay? I hope now this makes sense. Now let's go. We have completed /16. Now let's go to /8. How this works. Let me take this out. Yeah. /8, that means over here. That means the second octet will get updated. Okay. Let me take this out. Yeah. If the second octet will get updated, that means it will be, yeah, if the second octet is getting updated, that means second, third, fourth, all three are getting updated. Okay. So I'm writing it over here, X. Okay. So that means the first octet, that's 192, that is locked in. This is locked in. What will get updated is the second, third, and fourth, and they'll keep getting incremented. Okay, because this is the second octet we are talking about. Let's go to our cheat sheet. We have /8. So where is 168 fall in /8? We have our /8. 168 falls between 0 and 255. So this will be 0 and this will be 255. Okay, so this is our calculation is. Wanna check? Let's check. /8, calculate. Let me do one thing. Let me copy and paste this over here to check we've gotten this right. 192.168.0.0, we've gotten this right. 192.255.255.255, we've gotten this right. Usable 192.0.0.1 to 192.255.255.254, which means our calculation is correct. So let me first clear this board. Yeah. So now these are some of the, simpler calculations that we did. Now let's go to some absolute wackier calculation. Okay. Let's say if it is, I don't know. Let me just update this. Yeah. If it is like /27, or if it's like /11, how would the calculation go at that time? Okay. So let's do one thing. Let's make a calculation. Let me do one thing. Let me create some further examples and remove some absolute random numbers. Of course, that should be between 0 and 255 when it comes to IP, and when it comes to slash notation, it should be between /0 to /31, all the random numbers in between. Let's pick and let's experiment and play with this and just check if our logic is rock solid. So I have created these three examples. Example number one, 192.168.0.1. Example number two, 192.168.25.67 /27. And the third one is 192.168.92.243 /10. We're taking some absolutely wacky examples so that the more complicated the examples, the stronger your logic will become. Yeah? Make sense? Yeah. So let's look at example number one, 192.168.0.1 /18. That means the third octet. If the third octet is changing, that means this would be 168 dot, sorry. Yeah. So this, just let me just adjust this properly. Yeah. So see, if it is /18, which means the third octet. If this is the third octet, that means the third and fourth octet will get updated. The first and second will remain locked in. Yeah, because they are the network part, the first two, the last two are the host part. And if it is host part, and since this is the third octet getting updated, so it's safe to assume first one will end with 0. The network address, the broadcast address will end in 255. This will end with 1. And this will end with 254. Okay? So it's safe to assume that. Yeah? Because in the fourth octet, we are taking the entire range from 0 to 255. Now, in /18, what is the number in the third octet? You see this in 0. So where does 0 fall in /18? Let's open up our cheat sheet. /18, 0 falls between 0 and 63. Okay? So again, over here, let me repeat. Each block begins from 0 to 63, 64 to 127, 128 to 191, and 192 to 255. Okay, that's how it goes. This number should always be -1. This 128 should be always be -1. 192 -1. 256 -1. Okay. I hope that is clear in your head. So 0 falls between 0 and 63. So this will be 0. This one will be 63. Okay, and this will be 0 and this will be 63. Want to double check? Let's check. 192.168.0.1, yeah, 0.1 /18. Yeah, let me just copy paste this and let's cross check if I've gotten this right. Yeah, sorry. Yeah, network address is 192.168.0.0. We've gotten this right. Usable host IP is 192.168.0.1. Gotten this right. 192.168.63.254. 192.168.63.254. Broadcast is 192.168.63.255. Yep. Gotten this? Matching? That means our calculation is correct. And again, for those of you who are pressed on time, especially when you're in a production environment, you really may not have as much time to calculate. So please, your particular website, www.calculator.net, it's an IP subnet calculator. It's super fast, it's super efficient. It will save you a ton of time, and you'll be able to get your calculations in just a couple of clicks. Okay, but again, just because a calculator exists does not mean you forget how to, how the calculation we derive it in the first place. It's like it's saying if a calculator can, do the calculation for you for tables, for between 1 to 10 tables, like, 5 multiplied by 2 is equal to 10. Just because a calculator does that does not mean you should not know it yourself. You should. That's no excuse, okay? Just because a calculator does that. Anyway, let's get into it. So this, our calculation is correct of number 1. Let's go to example number 2, that is /27. If it's /27, that is this one. That means the fourth octet is changing, okay? So that means the first, second, and third will be just, yeah. The first, second, third, 192.168.25.x. First, second, and third octet will be the network part, and the last one will be the host part. Let me just ensure the template is created. the number in the fourth octet is 67. Let's check in /27 where does 67 lie. Okay, let's open up our cheat sheet. /27. 67 is between 64 to 95. Over here, you see this? I've highlighted it. 64 to 95. I know I'm using a lot of dark version, but dark version is easier for my eyes, okay? 64 to 95. So this will be 64, and this will be 95, and this will be 94, and this will be 65. Yeah? Wanna check? Let's check. 192.168.25.67 /27. Let me just copy the paste this. Yeah. 192.168.25.64, we've gotten this right. 192.168.25.95, we've also gotten this right. 192.168.25.65 to 192.168.25.94. Yeah? That means our calculation is correct. We've also gotten this right. And now the third one is /10. Where does /10 comes up, okay? That is the second octet, which means the second, third, and fourth will get updated. Let me just, only the first octet will stay locked in because it's the network part, okay? So, what is /10? That's the second octet. And what is second octet is 168. Yeah, before we go ahead, it's safe to assume this will be 0.0. It's safe to assume we can make it includes the full range. Yeah, if that makes sense. 255 to 254. 0.1. Yeah? This template makes sense is because because the third octet and the fourth octet we are including the entire range. So where does 168 fall in /10? Let's open up our cheat sheet. /10 168 is between 128 and 191. 128, 191. Okay, this will be 191, and this will be 128. Wanna check? Let's check. /10. Let me copy this, paste it over here, and let's check. Okay, 192.128.0.0. We've gotten this right. 192.191.255.255 is also correct. 192.128.0.1 to 192.191.255.254. We've also gotten this right. That means our calculation is correct and this is set. So now further we will look at some examples of 172 block, and I'll make it even more unhinged by the minute. Towards the end, I'm going to give you homework which is going to include the calculation of 10 block, and I want you to do that yourself, okay? But in the next one, let's explore the examples, 3 examples of 172 block, okay? So now we are going to look at some absolutely, random examples, because the more random and twisted the examples is, the better your logic will get, okay? So first, let's calculate this one, 172.18.55.105 /18. Where does /18 fall in the third octet? If it is a third octet, that means the first and second will remain the same. Let me just update this. 172. This one is 18. Yeah. And since this is the third octet, it's safe to assume that the fourth octet will include the entire range. So 0, 255, 254, and 1. Okay? So now that we have this in order, what is the third octet in this one is 55. Let's check where does 55 fall in /18. Let's open up our cheat sheet. /18, 55 falls between 0 and 63. So this will be 0 and this will be 63. This will be 63 This will be 0. Yeah? Wanna check? Let's check. Mhm. Yeah, let me just copy and paste the result and let's verify. 172.18.0.0, we've gotten this right. Then this is 172.18.0.1, we've also gotten this right. 172.18.63.254, we've also gotten this right. 172.18.63.255, that means our calculation is correct and this is, yeah, logic is sound. Now, let me just clear this up. Yeah. Now let's look at /11. Where does this come? That is in the second octet. If this is in the second octet, that means the second, third, and fourth, all three will change. Which means over here, and since this is the second octet that's in question, it's safe to assume that the third and fourth will include the entire range. Yeah. 254, this will be 255, and this will be 0.1. Okay. So yeah, the second octet in this example is 25. Where does 25 fall in /11? Let's open up our cheat sheet. /11, 25 is between 0 and 31. So this will be 0, this will be 31, this will be 31, and this will be 0. Wanna check? Let's check. Yeah, let me just paste this over here. Yeah. 172.0.0.0, we've gotten this right. Broadcast is 172.31.255.255, also correct. This is 172.0.0.1 to 172.31.255.254. Yep, that means our calculation is sound and correct. Now, this one is absolutely the most unhinged one. You will never come across this, but to ensure your logic is robust, the wackier the example, the sounder the logic is. Always remember that. Wackier the example, sounder the logic. Wackier the example, sounder the logic. Wackier the example, sounder the logic. Okay? So, in this one is the first octet. That means absolutely everything will change. Okay, over here, everything will get updated. And since the first octet, that is the one in question, that means the second, third, and fourth, the entire range will be updated. So it's safe to assume this will be 0.0.0. This will be 255.255.255. This will be 255.255.254. This will be 0.0.1. Okay? So, what is the first octet in here? It's 172. Okay, so where does 172 fall in /0? Let's open up our sheet. In /0, it falls between 0 and 255. So this will be 0, this will be 255, this will be 255, and this will be 0. Wanna check? Let's check. I'm using another site just to test that out, but essentially it's the same. Yeah. Yeah, so essentially the result is correct. Network address is 0.0.0.0. Broadcast is 255.255.255.255. And in the usable, it's 0.0.0.1 to 255.255.254. Okay. So this is how we have calculated it, and our calculation is correct. Okay. Now, my recommendation to you all would be to start giving yourself even more twisted examples and start calculating it yourself. For example, 10.5.10.0.0.24//3. I want you guys to calculate this yourself. Okay, give yourself examples like these. Another one I can think of would be 10.5.78.31/11. Another example, this is a homework. I want you guys to do it. And if you're able to do this, and if you have understood this, First of all, I feel really internalized the entire concept of the logic behind this. First of all, I want to give you a massive congratulations for getting so far, for getting this far, for having the patience. Because this video is not an easy video. It's a very math and a calculation heavy video. And if you're able to do this, massive congratulations. In fact, the most difficult part you have, the most difficult part you have overcome, and the journey from it is only going to be smooth as a downhill. Okay. The cheat sheet for this one is available in the description. It's public. You can access it whenever you want. And again, please give yourself as many calculations as possible. Keep practicing. And if you have understood this, your logic is sound, your logic is solid. The next video on was going to be absolutely simple. I promise you that. So thank you for watching this video, and I'll see you in the next one. Bye.